Alright, on to part B. Again, analyzing the graph of a quadratic, but this time my equation is in standard form. So it looks something like this. F of x equals a times x minus h squared plus k. Interestingly enough, when you have an equation in standard form, it is actually much easier to work with. So for example, I might have f of x equals to negative 2 times x plus 1 squared plus h. And the first thing I gotta do is identify my parameters. And my parameters are a, which is the number on the outside, negative 2, h, which is the opposite to the number on the inside, so that is negative 1, and k, the number on the outside, a, h, and k. Step number 1, like I said before, all the steps are the same, and so we go. Step number 1, determine the shape of the graph. Again, if a is less than 0, then it opens down. But one thing that I forgot to mention is that when the graph is opened down, it will have a max value. When the graph opens, when a is greater than 0, the graph opens up. So the graph will look like the previous one we just drew, and has a min value. The min will be down here, the max will be up here. And of course, so for our graph, our a is equal to negative 2, so that's less than 0, so our graph will open down. So at the end, when they're asking us for the min or max, it will be a max value. Step number 1. Step number 2, I have to find the y-intercept. That means make x equals to 0. You love making x equals 0, it's so much easier. And so when you make x equals 0, you find f of 0, which is equal to negative 2 times 0 plus 1 squared plus 8. And so that's equals to negative 2 times 1 plus 8. And so that's equals to 6. And so my y-intercept is 0, 6. And just plug and chug. To find the x-intercepts, you got to set the equation equal to 0. And so you would go y equals 0. So you have negative 2 times x plus 1 squared plus 8 is 0. Minus 8 minus 8. Negative 2 times x plus 1 squared equals negative 8. Divide by negative 2, divide by negative 2. And so I have then the x plus 1 squared is equals to 4. Take the square root, take the square root. So x plus 1 is equals to plus or minus 2. Again, we try and find a complete solution. So when we take a square root in an equation, we have to both go plus and minus. Subtract 1. So I have then that x is equal to negative 1 plus or minus 2. Well, negative 1 plus 2 is 1. And then negative 1 minus 2 is negative 3. Negative 1 minus 2 is negative 3. So my two x-intercepts are 1, 0 and negative 3, 0. Alright. Step number 4 is to find the axis of symmetry. Now this is where we start having some fun. In general form, to find the axis of symmetry, you have to remember a formula, i.e. x is equals to minus b over 2a. For here, you have to remember a fact. The axis of symmetry is always x equals h. Remember that axis of symmetry. Let me rewrite that. Axis of symmetry is x is equals to h. Remember that h that we found at the very beginning, h equaling -1. That's the axis of symmetry. So x equals -1. That's my AOS. No work is actually required when the equation is in standard form. That's actually part of the reason why it's called standard form. Step number 5. Find the vertex. Again, here we had some work to do. We had to take the axis of symmetry and plug it into the function and then work it out. The vertex is simply h comma k. Remember from circles, h comma k was the center. Here, the quote-unquote center of the parabola is your vertex. That's why we use those h and k. Well, I know h is -1. What was k? I forgot. K is 8. And so my vertex is at -1, 8. Just like that. No working out, nothing. I just take us straight to our answer. And so with that, I can graph and then find the remaining pieces of my steps. So step number 6 is graph. And -1, -2, -3, 1, 1, 2, 3, 4, 5, 6, 7, 8. The graph opens downwards. The y-intercept was at 0,6. That's right here. The x-intercepts were at 1 and at -3. The vertex was at the axis of symmetry was at -1. That should cut the graph in half. Again, you write axis of symmetry as a line, so write as x equals -1. And then the vertex was at -1, 8, right about here. The graph opens downwards, and so the graph of the function would look like this. Now that I have the graph of the function, I can go ahead and I can find my missing pieces. So 7, the domain, always the easiest because you do nothing. Domain is always all real numbers. It is a polynomial. The range, again, the range is the lowest y value to the highest y value. Well, clearly the graph is going down forever. So the lowest y value is -infinity, and the top right here, the y value is at 8. And so my range will be from -infinity to 8. Remember, in interval notation, you always give the smallest number first. -infinity is definitely smaller than 8. This graph has a max value. It opens downward, so we know it's a max value of 8. Again, that comes from the vertex. And again, the increasing and decreasing, the axis of symmetry splits the graph into 2 sides. But now, because the graph is upside down, the sides have been reversed. This is the increasing side. And over here is the decreasing side. It's decreasing from -infinity to 1. It's increasing from -infinity to 1, sorry. And then it's decreasing from -1 to infinity. So I am increasing from -infinity to -1. Notice I'm using a parentheses. It's decreasing from -1 to infinity. And that is because at -1, the graph is neither increasing nor decreasing. At that point, it's actually constant. And so you cannot use any square brackets around here. Okay, a little bit of bonus material. we can actually connect these two things right here and give you a nice little shortcut. If I have an equation in standard form, if I have an equation in general form, I want to create the standard. There's a nice little shortcut that we can use. The general form is f of x is equals to ax squared plus bx plus c. And then the standard form is f of x is equals to a times x minus h squared plus k. Well, the a's are always exactly the same. So that makes our lives really easy. So if I have an equation in standard form, I want to convert, and if I have an equation in general form, and I want to convert it to standard form, I already have half the problem done. I have a. The other key thing is that h and k make up the vertex. And so to find the vertex, you have to find the axis of symmetry, and then you just gotta plug it in. And once you have that, you have h and k, and then you can write it in standard form. And so there are many ways of converting to standard form, but this is the way that I found simplest and most straightforward. Instead of using completing the square, which is generally how it's done, you can convert to standard form much, much faster if you just do it this way. So an example. Convert the equation f of x equals to 2x squared minus 8x plus 2 to standard form. And first things first, I gotta identify a. A is simply 2. And so now that I have identified a, I have the first part of the equation. I know the number out front right here is going to be a 2. Now I gotta find the axis of symmetry. The axis of symmetry is simply minus b over 2a. And so that's going to be minus negative 8 over 2 times 2. That is 8 over 4, which is equals to 2. And so then that tells me then that h is equals to 2. So I have now found h. Last but not least, I have to find k. And to find k, you just take 2 and plug it into the equation. Just take this right here and plug it in, and that'll give you the y-coordinate of the vertex, which is k. And so I find f of 2, which is a whole bunch of 2's. 2 times 2 squared minus 8 times 2 plus 2. That's equals to 8 minus 16 plus 2, which is equals to negative 6. And now I have k. I know a is equals to 2. I know h is equals to 2. I know k is equals to negative 6. That's all I need to go from standard form from general form to standard form. So my standard would be f of x is equals to 2 times x minus 2 squared minus 6. This equation right here is exactly the same as this equation. They're just written differently, but they are exactly the same equation. Whatever number I plug into one, I will get the same answer if I plug into the other. So for instance, if I plug 0 into the first equation, so the general form was f of x equals to 2x squared minus 8x plus 2. If I plug 0 into this, I get 2, because everything else zeroes out. If I plug 0 into the general form, f of 0 equals 2 times 0 minus 2 squared minus 6, I will get the same answer. That is 2 times 4. 2 times 4 is 8 minus 6, 2. Doesn't matter what number I plug in. If I plug in the same number, I get the same answer. They're the same equation, they're just expressed differently. Alright, thank you.